Hey, how's it going? My name's TJ Davis, and for my project I created a Rubens Tube. As we learned in physics about sound, most sounds are waves produced by the vibrations of matter. And sound is also a mechanical wave, meaning the propagation of vibrations travels through a material medium, such as a solid, gas, or a liquid. With the Rubens Tube, we should be able to demonstrate the vibrations traveling through the material medium. We don't usually see this with air, but if we use propane and light that on fire, we should be able to see the vibrations going through it. What a Rubens tube is just a simple tube with drilled holes 1 inch apart on top. One end has a propane leading into it, and on the other end is this funnel attached to a glove which caps the other end, and the speaker will then vibrate the glove that's stretched across the opening, and that vibrating glove should send a disturbance along the length of the tube. The gas in this, the medium in this case, gas, returns to its initial condition after the disturbance has passed. And what is being propagated is the disturbance, not the medium. So if I set the gas on fire, it should hold its initial condition until a disturbance has caused it to change its position. So this is the gas, which is our material that we're going to be traveling through in its initial state. And if I put a note to the gas, the air molecules are going to be vibrated because this cone is vibrating at a specific frequency, which will be like a ping pong paddle, pushing the air molecules forward and back at a rapid rate. When it's going forward, it should create an area of compression, and when it comes back, it should create an area of rarefaction. So it should be compressed, rarefacted, compressed, rarefacted. Same thing as high pressure, low pressure, high pressure, low pressure. So if I play a note, a C, which is at 440 Hertz, it should create a disturbance. Alright, let's try a higher note. A high C at 880. No, that's too high. Alright, that one should work. So as we see, the note, the wave is creating the areas of high pressure, low pressure, and high pressure. So the note is traveling through it, and then once the disturbance has passed, it should go back to its initial state with a little help from a lighter. Let's get these going again. Maybe I need a little more gas. More fire is always better. Alright. And as we see with different notes, we have different wavelengths and frequencies. Okay. And now, normally when we listen to music, we don't see this single wave, or we don't realize what's going on, because in music it's all these notes coming together, playing at the same time, so we never really notice what's going on. And when we have music, this is what we get. Of all the other ones. The most overwhelming one is the bass kicker and the bass, because it creates the most vibration through the song. So when you hear the bass, you hear the flames going up, and also with the bass playing the notes, that wave is going through there, but you don't really notice it because of all the other instruments. So with this, we can see that waves do travel through space, they do affect the medium, or they travel through the medium while creating these sine waves. And there you have it, the Rubens Tube.